Good morning, viewers. This is Kasturi Day. Today, I'm starting with a new chemistry chapter according to ICSE syllabus, class 9. Okay. So, before I start, I will request you to please to subscribe my channel if you have not subscribed there, and if you are a new viewer to my channel, then please ring the notification bell because that will notify you as soon as a new video is uploaded. And before everything, I will wish you a very happy Diwali. I think you have spent a very happy Diwali and Chhat Puja, and also Jagadhatri Puja, which is very coming soon. Okay, which is coming very soon. So please enjoy and please be safe, and also do study a little bit so that that will help you in your exams. Okay, and the least what I want to say is please to meditate before you start your day, because that will help you in increasing your concentration, in increasing your interest in the studies, and whatever job you are doing, that will become very easy for you, and that will be very interesting for you, and you will become very happy in doing so. So for meditation, we will start with that, and for that, please do concentrate on a point of light. We'll continue for just 1 minute. Please do join with me. So please concentrate on a point of light. Think that light is falling on you, and you are becoming lighted up with that light. Whole body of yours is being lighted up, getting energized, getting powerful, becoming pure with that light. You are becoming happy also. You are getting interest in whatever the job you are doing. Concentration power is increasing. Your memory power is increasing. You are remembering many things which we are not doing so. You are becoming successful in life, getting good marks. The marks that not means that is you are thanking God for whatever He is giving to you. Thank you, God. Turn back to your studies, okay? So let us start with the chapter that is the periodic table. It's a new chapter on chemistry. So let us start with. So what is a periodic table? Periodic table is a tabular array of the chemical elements organized by atomic number. So on the basis of atomic number, the chemical elements are organized in a tabular form. Okay, and that is known as the periodic table. Okay. Now we know that matter which is composed of only one type of atom is known as an element. One type of atom is present and it is called an element. People have known about some elements like gold, silver, iron, mercury, and tin for hundreds of years. But scientists later on discovered in the 18th and 19th centuries many other elements. Okay? This created an instinct in humans to classify these elements. Lots of elements were there now. So some elements which were discovered earlier, some later on. So all these elements, so many elements were there too. So the scientists, or rather many people, all people could not remember all those elements. So for this, they wanted to classify these elements. The scientists wanted to classify these elements. Okay. So these elements are assorted in a tabular arrangement. In the table form, they were arranged, wherein a row is a period and a column is a group. Okay? The row of the table, that is a period, that is called a period, whereas the column of the table, they were known as the groups. Okay. Now elements are arranged from left to right, from left to right, and from top to bottom this way, according to the increasing atomic numbers. So from left, which is on the extreme left, that will have the least atomic number, and that will increase when you go to the right. In the same way, similar way, that is with the the topmost element will have the least atomic number, and when you go down, it will increase the atomic number. The atomic number will increase. Now, the elements having the same valence electronic configuration, element having the same valence electronic configuration are placed in the same group. Okay? Like electronic configuration is 288, like that. No, you have studied in the previous chapters. So in previous classes also, that the electronic configuration of the of the elements. So when the elements have the same valence electronic configuration, those elements are grouped in the same group. So similar chemical properties were there. Okay. Now elements having an increasing order of valence electrons, elements which have a increasing order of valence electrons increased. So they are placed in the same period. Okay, period means in the same row, and group means same column. Okay. With the increase in the energy level of the atom, the number of energy sublevels per energy level increases. So energy level of the atoms increases. So the number of the sub-energy per energy level also increases. Clear? Then the first 94 elements of the periodic table, are naturally occurring. I repeat, the first 94 elements of the periodic table are naturally occurring. They are naturally occurring elements, 94 elements of the periodic table. While the rest, that is from 95 to 118, they have only been synthesized in the laboratories or the nuclear reactors. Here, so first 94 are naturally occurring. It can be found naturally. And the other elements, the rest of the elements, they are prepared in the laboratories or in the nuclear reactors. Here, from 95 to 118, till now we have 118 elements known. Okay. Now, what is the need of the classification of the elements? See, with this, with the discovery of the elements, the chemists more systematically, this classification of the elements, that means they were arranged in the periodic table, no, in the tabular form. So why this was necessary? With this classification, the chemist more systematically and orderly analyzed and understood the properties of the elements and their compounds. So the chemist could, by this classification, by this tabular form of the elements, the chemist could systematically and orderly analyze and understand the properties of the elements. Okay, they could analyze and understand the properties of the elements and also their compounds. Okay. Now, with this classification, again, the chemist predicted the properties of the elements and the compounds based on the positions in the periodic table and the vice versa. Okay. So, as the positions in the periodic table are, as the position of the elements periodic tables are, the chemist could predict the properties of the elements and their compounds and vice versa. That is, according to the properties, they could tell the position of the element in the periodic table. Okay, clear, excuse me. With this, it became easier to study, understand, compare, and contrast the related properties among the elements and the compounds from the different groups. So, what happened with this classification, with this tabular form of the elements, it became easier to study the elements, to study their compounds, the elements' compounds, okay, to understand them, to compare them with the other elements, and and compare and contrast the related properties among the elements and their compounds for the different groups. Okay? So they could systematically and orderly analyze and understand the properties of the elements and their compounds. The chemists could predict the properties of the elements and the compounds based on their positions of the periodic table and vice versa. And also it became easier to study, understand, compare, and contrast the related properties among the elements and the compounds from their different groups. Okay. Now, reasons for early classification proving unsatisfactory. That means what? Why this? We know that classification was needed and they did the classification, but that became unsatisfactory. Why? First, in the earlier classification, which became unsatisfactory. Why? Okay. Why it became unsatisfactory? The classification of the elements. The classification of the elements? Why became unsatisfactory? Okay. So in the beginning, the chemists tried to classify the elements on the basis of the factors. Certain factors they classified the elements on depending on the certain factors. So what were the factors? Density, malleability, ductility, etc. Okay, and also to consider whether they are metals or non-metals. But all of these early classifications proved unsatisfactory. Okay, so these early classifications, they proved unsatisfactory. Why is this so? The number of elements falling in a particular group, the number of elements which were falling in the particular group, that is in the particular column they were arranged in, so in the table, they did not serve the purpose of generalization as they were so large. These elements were so large that they did not serve the purpose of generalization. Okay. Under different conditions, some of the considered characteristics varied. So different conditions, when they're like different conditions means like if the temperature was increased or if the pressure was increased or if the like that some other factors increased or decreased the conditions, according to the variation of the conditions, the characteristics also varied. So when the characteristics varied, their group could not be identified properly, or rather they could not be placed in the proper group. Okay. So again, third point is certain elements showed both metallic and non-metallic characteristics. So that also created a problem. That also created an unsatisfactory result of this periodic classification. Okay. That's why scientists were in search of characteristics of an element that would never change. So, as they were in the beginning, as they depended on the, or rather, as they classified on the basis of certain characteristics, that proved varied due to certain conditions, or they did not serve the purpose, as they were so large, or there were some metallic or non-metallic characteristics also present. So these characteristics, on the basis of the factors which they did the classification, that did not prove right. Okay, that's why what happened, they searched for certain characteristics of the elements that would never change. Finally, William Prout discovered the atomic mass of that element, of an element. Okay, he found that atomic mass is a characteristic of an element on which the classification can be done. Okay, on the basis of which the classification can be done. That never differs, which therefore forms a truly scientific basis on the satisfactory scheme of classification. So this research was going on, and certainly, finally, William Prout discovered the atomic mass as the characteristic feature on which the classification could be done, as these atomic mass did not change. It does not changes. So that's why this characteristic was considered to be on the basis of their difference. Now we come to Dobereiner triads. Okay, sorry, I spelled I pronounced it wrong. So Dobereiner Dobereiner triads. Okay, triads. So they are group of elements. So what is Dobereiner triads? They are group of elements with identical properties discovered by Johann Wolfgang Dobereiner. He was a German scientist, German chemist rather. So he was a German chemist, and he discovered the group of elements with identical properties. What did he observe? He observed that the groups of three elements, that is the triads, as he called it, the groups of three elements, so he called them triads, could be formed where all the elements shared the same physical properties and the chemical properties. Okay, so he grouped three elements and he called them triads, and these three elements which he grouped would share the physical. On the basis of this classification, he grouped these elements on the basis of the same physical and chemical properties. Now, Dobereiner's law of triads also stated that the atomic mass of the first and the third element, like A, B, C, if we consider these three elements as a triad, then A and C, the atomic mass of A and C, would be approximately equal to the atomic mass of the second element in the triad. Okay, so he made the atomic mass of the first and the triad, summed them up and made an average which was almost equal to what? The atomic mass of the second element of the triad. He also suggested that this particular law could be extended for the other quantifiable properties of the elements such as density. Okay, so he also suggested that this particular law, that is atomic mass summing up that is average atomic mass of the first and the third element would be equal to the atomic mass of the second element of the triad. That law could be extended to the other quantifiable properties of the elements such as density. Okay? The alkaline earth metals, strontium, barium, and calcium made up Dobereiner's first triad. Dobereiner's first triad was strontium, barium, and calcium, which was discovered in 1870. Okay, discovered this alkaline free earth metals as a triad, and they formed into a triad. This was the first triad which he discovered in 1817. The metals were strontium, barium, and calcium. He arranged the element in increasing order of atomic masses and found that the atomic mass of the middle element was approximately equal to the arithmetic mean, that is the average of the atomic masses of the other two elements of that triad when they are arranged in the increasing order of atomic masses. For example, this is lithium, sodium, and potassium. The atomic mass of lithium is 9, potassium is 39. Okay, the average of the two atomic number is 23. So that is equal to atomic mass of the sodium. So this formed a triad: lithium, sodium, and potassium. Next is Dobereiner's first triad which he discovered, that is lithium, sodium, and potassium. This is an example of the triad. This triad was made up by the alkali metals, that is lithium, sodium, and potassium. Arithmetic mean is 7, 39. Sorry, it should be 9 and 39. That is 23. Okay. So that is equal to the atomic mass of sodium. Okay, and each has a valency of 1, and all these are metals. Okay. Then comes barium, strontium, and calcium. Okay, so formed another triad where calcium is 40 atomic mass and barium is 137, which is equal to the average mean is 88.5, which is identical to the atomic mass of strontium. All these three are metals, and each has an oxide that is alkaline in nature. That's why these metals are known as alkaline earth metals. Okay, and each is a valency of 2. Okay, so that's why they form the triad. Next is Why this law was discarded? What is the reason behind them? Why this law of triad was discarded? Although Dobereiner's triads made an attempt to classify the elements according to their properties into groups of three, still had various reasons for the law was discarded, for which the law was discarded. Okay, so what were the reasons? Many new elements were discovered in the 18th and the 19th century, which made the classification of elements in the Dobereiner's triads difficult and also impossible in some cases, even within the same family. Even if even they were in the same family, when these new elements were discovered in the 18th, 19th century, 18th and 19th century, they could not be classified in the Dobereiner's triads. Rather, it was very difficult to classify them according to Dobereiner's triads. And sometimes it was impossible. In some cases, it was impossible, and even in the same family also it was impossible. Only 5 Dobereiner triads could be identified. The 5 of the Dobereiner triads could be identified, and new elements could not be grouped in the Dobereiner triads. Okay. There also existed several elements at the time of Dobereiner triads formation that did not fit into the Dobereiner triads. There also existed several elements at the time of Dobereiner triads. Many elements were there in the Dobereiner triads formation, but that did not fit in the Dobereiner triads. One thing is, new elements were discovered in 18th century that did not fit into them. Even the existing elements which were there in the during Dobereiner, that also did not fit in his trials formation. Okay, this resulted in disordered element collection, and that's why this law was discarded. Okay? Next is, for example, see in the triad of halogens, fluorine, chlorine, and bromine. Fluorine is 19, chlorine is 35.5, and bromine is 18. So it is observed the mean of the atomic masses of fluorine and bromine, the first and the last, first and the third one. So that will, the average is 49.5. And the atomic mass of chlorine is 35.5. There's a huge difference between the atomic masses. So the atomic mass, which is not, this 49.5 is not at all very close to the atomic mass of the chlorine. So that this did not follow the law of triad. So these type of reasons were there why this law was discarded. So next we move on to Newland's law of octaves. So after the discarding this of this Dobereiner's triads law, Newland he gave the law of octaves. So who was a Newland? Who was Newland? He was a British chemist. Okay, John Newlands. He attempted to combine 62 known elements in 1864. 62 known elements were combined in 1864. He arranged them in ascending order according to their atomic weights. So now, till now, it was atomic mass and atomic number. Now it came to this John Newland, he told on atomic weights and discovered the properties of every 8th element were the same. He found that the properties of every 8th element were the same. Okay, this resulted in the discovery of Newland's law of octaves. So octave, this suggests, the name suggests that it's the 8 concerned with 8. Octa means 8, no? So it considered, this name suggested there is some relation with 8. So that's why the 8th element, will have the same characteristic of the first one. Okay. He contrasted the components. Okay. Components proximity to the musical octaves. He compared this component's proximity to the musical octaves, where every 8th note is comparable to the first. 8th note is compared to the first. According to the law of octaves, while arranging the elements in the increasing order of their atomic masses in the periodic table, the eighth element properties are similar to that of the first. Okay, the properties of the eighth element that resemble the properties of the first element. Okay, every eighth element. The elements have been divided into horizontal rows, and each row are comprised of 7 elements. Okay, so each row was there, horizontal rows, and each row comprised of 7 elements. 7 elements were there. Then, so each element is a parallel row. In the parallel row must have the same physical and chemical properties, which is not true. Which is found that it is not true. So he placed the same elements in the same row. I mean, in one row, which were 7 elements were there, and this should have the same physical and chemical properties, but it was found that this was not true. The periodicity is only valid till calcium. Till calcium, this valid. But later on, something or the other there was disturbance. Okay? So what were the advantages of NEWLAND'S classification? What were the merits? This law establishes a framework for the first time for classifying items with comparable features into groups. That is a distinct periodicity in the particular in the properties of the elements. So this law, NEWLAND'S law, he established a framework for the first time. He gave for the first time a framework for classifying the items, or classifying the elements with comparable features into groups. What is that? That means a distinct periodicity was there in the properties of the elements. Okay, the system gave the government extensive authority to organize all known elements into a tabular format. Okay, so all known elements, they were organized in a tabular form. Okay, that gave a government extensive authority to organize them in the tabular form. Now, NEWLAND'S law of octaves was the first to be based on the atomic weight, linking element properties to the atomic masses. Okay, it was based on atomic weight, linking what it linked with the element properties to the atomic masses. Okay, for the lighter elements, this method performed significantly better. The lighter elements, this law was perfectly better. Okay, it's more or less rather perfect. But in case of heavier elements, this proved bad. Okay, this did not prove correct. So I will come in the demerit section there. Like lithium, sodium, and potassium, for example, were combined, and this were the lighter elements, and this law significantly proved the better now. Now, for this work on classification of elements, the Royal Society presented Davy Medal to NEWLAND in 1887. He was awarded from the Royal Society a Davy Medal. The Davy Medal was awarded to NEWLAND in 1887. Next, we come to some demerits, and then these demerits were the reasons why the law of octaves was discarded. Okay, after this came Mendel's law. So, why this law of octave was discarded? Let us see. First point is, out of the total 56 known elements, NEWLAND could arrange elements only up to calcium. Other elements were left out. So from 56 known elements at that time, only till calcium they were arranged properly, and other elements, heavier elements, were left out. Every eighth element did not show the properties which he said that every eighth element will have the same properties as the first one. This was not correct for every eighth element. Just 56 elements were known at that time of NEWLAND, but later various other elements were discovered and they were not fitting into his law. To adjust the existing elements ordering, NEWLAND placed 2 elements in the same position, which differed in the physical and chemical properties. So to adjust all the elements in the ordering, he placed two elements in the same position, but they differed in the physical and chemical properties. Okay. For example, iron is an element which resembles cobalt and nickel in its properties. Okay. But iron is placed far away from these elements. Okay. Then the periodic table did not include the noble gases as they were not discovered during that time. The noble gases were left out. They were not fitting into this. They were not considered in this table classification. So these conditions were there why the law of Octaves was discarded. So next it came the Mendel's periodic law. Mendeleev's, sorry, not Mendel's, Mendeleev's periodic law. Okay, so we will discuss in the next video. Till then, please go to this. If you have any doubt, please do write me in the comment box. And you can also refer to my email ID, that is kasturi74@gmail.com. You can write there also. Okay. And if you like the videos, press the like button, share with your friends so that they can also be benefited from these videos. And if you have not subscribed yet, or if you are a new viewer to my channel, please to subscribe and ring the notification bell, because that will notify you as soon as a new video is uploaded. And if you want to concentrate on meditation, or you want to, anybody of yours want to listen to some Bengali, this one religion, rather some what do you say, that some spiritual knowledge you want to gain, then you can refer to my new channel. Okay, it's MouBK. You can get it there. Okay, so please do subscribe that channel also. Thank you for joining, and have a good day.